we are going to do electrochemistry. Electrochemistry is the branch of science which deals with the conversion of chemical energy into electrical and electrical to chemical energy. So here we will see we have to do the topics galvanic cell, which is also known as electrochemical cell. And then we'll do electrolytic cell. Their definition, their differences, and to find out EMF of this galvanic cell. So starting from the differences between these two, and before that, what are they? We have seen them in our everyday life, especially this galvanic cell. So we are starting from the difference of these two. We are doing first difference is that what is the galvanic cell? This is the cell which converts chemical energy into electrical energy, as inverter battery in our house. So in our houses we have inverter battery where chemical reaction is going on and we are getting electricity. So what is galvanic cell? It converts chemical energy to electrical energy. While electrolytic cell, it converts electrical energy to chemical energy, electrical to chemical energy. Where we have seen this electrolytic cell, these are the cells which are used for electroplating, for the purification of metals, for the decomposition of water in lower classes. We have done this. So here we can write down the examples of them. Here example we can write down inverter battery, in this we can write down the example of purification of metals, or decomposition of water, that is done in electrolytic cell, as well as some more decompositions are done. For example, decomposition of sodium chloride in the aqueous form or in the molten form, that is also done in this electrolytic cell, because in that cell we are passing electric current, and then decomposition of that function is done, that work is done. Here in galvanic cell, the electrodes cathode and anode are there, same are there in electrolytic cell also, but what is the difference we have to see. Here cathode and anode are having different charges from the electrolytic cell. Here cathode is positively charged, anode is negatively charged in galvanic cell, while in case of electrolytic cell, cathode is negatively charged while anode is positively charged. But the similarity is that anode here, in both the cells, oxidation takes place at anode and reduction at cathode. This you can say this is the similarity. Here also reduction, oxidation. For the better understanding, we can see that in galvanic cell, if we learn or if we keep in mind LOAN, lone, for galvanic cell. In galvanic cell, on the left hand side, there is oxidation going on, and that is anode, which is negatively charged. This happens in galvanic cell, where oxidation is going on anode and that is negatively charged. But in electrolysis cell, oxidation is going on anode but that is positively charged. Now, the third difference, mainly we have to see how this arrangement of these cells are there. In galvanic cell, we can take the example of Daniell cell. Daniell cell is made up of zinc and copper. This is zinc copper cell, where zinc obviously is more reactive metal than copper. How we can say this is more reactive? For that we have to see electrochemical series. In that electrochemical series, more reactive metals are there, less reactive metals are also there, and they are differentiated by hydrogen. There we have learned also in the lower classes. In this way, some elements we learned: केदारनाथ का माली, आलू जरा फीके से पकाता है क्योंकि होंगे आगे और पेशेंट. Few metals we can learn with the help of this: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, gold and platinum. Where hydrogen has zero electrode potential, 0 volt. The metals which are more reactive, they have negative electrode potentials. They are written in the series. Few of them I can write down here. For example, zinc is having minus 0.76 volt. Then more and more and more negative goes on. For potassium, minus 1.26 volt. For copper here, plus 0.34 volt. Then more and more positive becomes as we go down from copper to mercury to silver. Silver is having, for example, plus 0.80 volt. We have not to learn them. There will be the given values there. But we should know that if they are more reactive metals and less reactive metals, if two metals are arranged in a galvanic cell, then more reactive metal get oxidized and less reactive metal get reduced there. So here also, if we see the zinc and copper, here if you see zinc is here, copper is below, so zinc is more reactive. So whenever zinc and copper are connected with each other, then zinc will get oxidized and copper will get reduced. Now what is the difference between the two? The galvanic cell, in this, there are metals connected but they are kept in different containers in different electrolytes. So in this, one half I have drawn here, in which the more reactive metal zinc is taken, or zinc rod is taken, which is dipped in zinc sulfate solution. While in the other container, the other metal is taken, copper metal, which is dipped in copper sulfate solution. This is electrolyte, copper sulfate and zinc sulfate. This is electrolytic cell. Now they are connected with the help of, now here it is wrong. We have not to draw battery here because this itself is a battery. So we have to draw here voltmeter, key. These are there. Now if we press the key, circuit will not be completed even, because here this is open circuit. So to complete the internal circuit, this salt bridge is taken. This is the U tube, tube in the U shape made up of glass, and in which inert electrolyte is filled there in the semi-solid form. Semi-solid form means it is mixed with some substance which is not purely liquid and not purely solid, because there will be problem in conductance. So it is the substance like starch, or agar-agar jelly-like substance in which some inert electrolyte is filled, for example, ammonium chloride, ammonium nitrate, potassium nitrate, etc. They are inert electrolytes. What is mean by inert electrolyte? It means that the electrolyte or substance which does not react with the chemicals present in both the halves, both the containers, out of which this left one is oxidation half, which is here negatively charged, which act as anode here. The right one is where reduction is going on. This is reduction half. This is positively charged. Here it is named as cathode. It is acting as cathode. Now in this cell, electron transfer takes place, or you can say the direction of flow of electron is from anode to cathode. This way. This is electron flow direction. And current flow direction is just opposite to electron flow. Now this cell is represented by only showing these species which are present there, not by drawing this diagram. That is known as cell representation. Cell representation can be written as cell representation where solid species are written outside. Outside means with the help of one vertical line, this species of oxidation half are separated. Solid zinc outside, zinc ions inside. Then two vertical lines are drawn which are showing this salt bridge. Then the right half, that is copper in the aqueous form, separated by one vertical line, copper in the solid form. Now it is very clear that this part, this is oxidation half, where oxidation is going on, known as anode, and it is negatively charged. All information is gathered here. The other part is reduction half, which is cathode and which is positively charged. And here we can show electron flow, we can show current flow direction. Now we can find out EMF, electromotive force, or cell potential of this cell. How can we find out? First of all, what is EMF? Electromotive force. This is equal to E cathode, or electrode potential of cathode, minus electrode potential of anode. So electrode potential of cathode is represented by E cathode, or E only C we can write down as subscript, or we can also write down E right minus E left. So E cathode minus E anode. EMF or cell potential, we can find out standard cell potential by taking standard values of electrode potential of cathode and anode. Now, what is cathode potential? Cathode is here copper. So cathode potential can be written as copper 2 positive oblique copper, that is 0.34 volt in positive values. While electrode potential of zinc electrode, this is written in this way. This is written as minus 0.76 volt. These values I have taken from the table. Now if we put the value, we get Cathode minus anode means 0.34 volt minus 0.76 volt, that is plus 1.1 volt. And this is in positive values. It shows that the reaction is feasible. This cell will work, cell will be feasible. So, and whatever voltage is obtained from this cell, that is written there, that is calculated. This is known as EMF of the cell. Now, what are electrode potentials? That we have to see. Electrode potentials, they are the comparative oxidizing or reducing ability of any metal or of any element that we have to calculate